طيب بسم الله الرحمن الرحيم. In the beginning, we'll just go through a brief introduction, which is chapter 1 in the book. I'm going through the slides after I modified significantly the slide provided with the book. So at the beginning, why again, I always like students or anyone who presents to try to always ask yourself, why is this important? Why we need to study this topic? Why I need to read about this topic? So the motivation is always the first thing that will trigger you to know more about this topic. So why wireless communications? Why this is important? Well, wireless communication constitutes the largest network system on the internet. So the number of subscribers of mobile communication services is actually growing exponentially until maybe now it topped the number of population on Earth. So we have 9 billion subscribers for different mobile communication services, which is more than the number of population on Earth, which means that each person is subscribed to more than one wireless service on average. Okay? So wireless communication touches just about every single discipline in our lives. And it's all because of the concept of mobility and portability, which increases the convenience of how people approach their daily activities, right? So we need more, we always strive to have more convenience. And this is what wireless and mobile communications provide us. It gives us the ability to be ubiquitous, to be able to move, and be able to access our data and services from anywhere at any point in time. Okay? So mobile devices dominate the internet. So nowadays, I think we have very, very few number of devices that do not have wireless in it. Even our laptops, our tablets, every single device now is actually equipped with wireless. Why? To facilitate the mobility and portability. That led to the fact that mobile applications have also dominated the internet. So we have now IoT applications. So we have applications that revolve around the fact that wireless devices are highly portable and mobile. So you have now glasses that allows you to monitor and analyze and get information on the go. We have smart devices on campus that allows you to analyze and get and even record attendance of the students and so on and so forth as they go. But of course, with new possibilities, there are always new threats, right? So we know that mobile communications are always associated with mobile attacks. So security is one of the threats that face mobile communication technologies. So these types of communications have affected, as I said, all the daily activities of our lives on 24/7. So we have now people at home being monitored on a 24/7 basis about maybe their vital signs, their mobility at home for smart home applications and so on and so forth. So all these applications are facilitated through mobile communications. So there are two aspects of mobility. There is mobility and portability. There is slight difference between the two. So portability talks about the ability to be able to carry the device and connect from anywhere at any point in time. Okay? And that doesn't necessarily mean wireless. So the fact that we actually move our laptop from one location to another, it doesn't mean that this laptop has to have wireless. Because in the past, we had laptops that does not have wireless. And when we move from home to work or to school or whatever, in each of these places, we have to hook the laptop to wired, to Ethernet, right? But the laptop itself is low weight and it allows you to port it from one place to another, right? Also, mobility, same thing, does not have to necessarily be wireless. As we said, just the example now, we can move, okay? We can move inside a car and hook the laptop or the device to a wire or to any connection and connect using wired. But we can move around. So we can move from one place to another and connect using wire, which is very rare nowadays. The more common scenario is that portability is associated with mobility, which is associated with wireless. Okay? So we have no wireless and no mobility, which is like a stationary computer, like a workstation, has no wireless, nothing, and it's hooked up to the wall, and it's connected to the power source, and that's it. So no mobility and no wireless. We have notebook in a hotel, which is not necessarily wireless, but it's mobile, which means that it's portable. And we have wireless, but not mobile. Like if you have, like, you know the microwave towers, you have big towers, they are fixed, they are not moving. But they facilitate like microwave links point to point. And this is wireless. But they are not moving. Okay? And they usually use it as an infrastructure to have like a wireless infrastructure which goes through buildings and stuff. Because sometimes, like if you have two towers and you want to build like infrastructure between these two towers, then you have to go through buildings and bridges and so on and so forth. And sometimes this is not possible. So instead, wireless in that context is being used for easy deployment. Okay? So another benefit of wireless is to facilitate easy deployment. So instead of digging wires everywhere, you can just use wireless to simplify the establishment of the infrastructure. Okay? But that doesn't mean that these towers are moving. They don't have to be mobile. They don't have to move around. Okay? But of course, 95% of the time or more, we have always wireless associated with mobility. So when we talk about wireless, we talk about mobility. So the demand for wireless communication creates the need for integration of wireless networks into existing fixed networks as well as mobile networks. So we have many wireless technologies and wireless standards. We have wireless LANs, or what we call 802.11, with all its variations. We have broadband, we have mobile IP extension, broadband technology including GSM, and now we have 802.16 or WiMAX, and we'll cover some of these as part of the course. But did you ever ask yourself why we don't have like one wireless standard? that works for everything? So why do we have all these varieties of standards? Why we don't have like one standard that includes all the wireless technologies and services? Why do we have 802.3, or sorry, 802.15, 802.11, 802.16, and we have HSPA, we have GSM, we have UMTS, and we have, all these are standards, and each one of them, they have hundreds of pages of specifications. They are very, very detailed, okay? And they are numerous. So why do we need to have all these standards? Why not like just one standard for all wireless technologies? The bad news is that we cannot have that. And as part of this course, we'll try to answer the question of why. Because for each context, you will find different characteristics of the wireless signal, which forces you to have specific standards that addresses this particular context. Whether, for example, like short range or long range, whether low power or high power, and we'll see how the wireless signal gets really affected by these different parameters. It gets affected fundamentally, which changes the entire game. And that's why we need to have different standards for each context. Not just one standard that works for, there is no one size fits all in this case. You need to have different standards to address different category or different context, and based on that you can design different applications for that context. Okay? So we'll discuss these characteristics and details in this course. We'll understand actually how the environment affects the wireless signal. And based on that, how the wireless signal gets affected and how the characteristics of this wireless signal gets affected, based on that, we need to design different standards to address the wireless signal in that particular context. So nowadays, we are in the era of Internet of Things. So when we talk about Internet of Things, it includes everything. So the simple definition for Internet of Things is everything. So it includes all devices, actually not devices, all things. So everything is going to be connected to the internet. Everything is going to have an IP. Everything. Even our clothing. Our appliances at home. Okay? Everything. Our watches. Everything is going to be IP based. So one single human being is going to carry with him or her tens of IPs or IP related devices. Okay? Of course, potentially all these devices are going to use wireless. So in that case, you need to understand exactly the characteristics of these devices when they communicate in a certain context. Because when they communicate with each other, is different from the fact that they need to communicate with the infrastructure. Those are two different types of communications. And we'll see the wireless communication in those two contexts are totally different. And that's why we need to have different standards for each type of communication. As I said, everything is going to be connected to the internet. In the hospital, every single device is going to be able to communicate with other devices, going to be able to communicate with the internet and communicate possibly measurements, vital signs of patients and stuff to different locations at any point in time. Moving ambulances or moving cars will be able to communicate things beforehand to the hospital and things like that. Appliances at home, in a smart home context, will be able to have like some IP, some storage, some computation capabilities. All these devices are are going to have some computational capability. So you can leverage that. If you have hundreds or thousands of these devices, you can possibly aggregate their computational capabilities to do something big. And this is what we call this is what we call fog computing. Okay? So we can sort of aggregate the computational capability of all these devices towards achieving a big mission. So, of course, in that perspective, there are tons of applications. So vehicles, of course, QMIC is working on vehicle communication a lot, at least part of it. So in vehicle communications, we have vehicle-to-vehicle communication, we have vehicle-to-infrastructure communication, and in each of these types, there are certain standards. So for vehicle communication, one very important characteristic that affects the standards in this context is the high mobility. So we'll see how the high mobility affects the wireless signal, and that's why we need to have specific standards for this type of communication. Because if you have two cars are moving in a very high speed, the wireless signal itself changes. The frequency response of the wireless signal changes. So you need to be careful when you talk about communication vehicle to vehicle when they are highly mobile, versus if a vehicle wants to communicate to the infrastructure, and so on. So if two devices are talking to each other without involving infrastructure, we call this ad hoc communication. In an application level, we call this peer-to-peer. So in the network level, we call that ad hoc communication. So we communicate directly without involving infrastructure like access point. So if two people or if two devices want to communicate with each other using Wi-Fi, they have to go through the access point. So each type of communication, each piece of message has to go through the access point. Okay? So if we want to communicate directly to each other, now we have to use different technology, like Wi-Fi Direct or something, or we can use Bluetooth. Okay? Because this type of direct communication with no centralized controller, again, has different characteristics. Okay? So all these types of communications, with all these factors, mobility, power, range, no centralized control and like ad hoc control and stuff, all these factors affect the fact that you need to have different specifications and different rules to govern the communication in different contexts. There is no one size fits all. Okay? So this is how the architecture of the vehicle communication looks like. Of course, it's not our topic, but you can, from one vehicle to another, we use what we call ad hoc communication. Of course, here there are particular standards to control the communication vehicle to vehicle, versus if we communicate to the infrastructure, we can use one of these standards, whether 3G, or we can use wireless LAN, or we can use GSM, or we can use LTE, or we can use Tetra, or we can use CDMA 2000. So we'll take some idea about some of these standards. So we'll study the different characteristics that each standard tries to address, okay, in order to really be able to, at the end, appreciate first, why do we have different standards for different contexts? And then, from looking at certain contexts, then we know roughly which type of standard that fits in that context. And this is very important for us as communication engineers, that when we see a particular context, then we say, okay, so we need to use possibly this type of technology or this type of standards. It will fit in that context efficiently. And that's very important. When you design your system or your application, you need to identify what type of technologies or standards that need to be engaged in that particular context. Another set of applications, which is like health monitoring. Of course, in that perspective, we're doing a lot of work, at least in our group. So wireless remote monitoring has always been very challenging application scenario, because this technology needs to advance a lot because of the fact that the patients need to be monitored 24/7, and there is huge amount of real-time data that needs to be carried or acquired from these patients at any point in time. This type of data needs to be also processed in real time. So you do need to acquire it efficiently. You do need to communicate it efficiently to the cloud, and then at the cloud you need to process it. In fact, in that perspective, we have another, again, paradigm, which is like edge computing, where the processing is happening closer to the patient, and in that case, we enhance the remote monitoring. In fact, this is our work. And in fact, on Sunday, I'll have a talk about this, inshallah. So health is another set of applications that gets really affected by mobile communications. And in fact, of course, this actually allows the patients to be monitored 24/7 on the go while they live their own life. So they live normally. They don't have to be stuck in the bed in the hospital for a long time. They can move around, they can live their life. But the problem is that they sometimes run through threats, like someone is having a seizure, someone is having a heart attack. The possibility is very low, but it's there. And what happens, it's life-threatening situation. So you never know when it happens. Of course, there is some research to try to predict it, but there's always a possibility that it happens, and you don't really have any action to help the patient during that situation, and in that case, you can have a life-threatening situation. So with these types of technologies for remote monitoring, you have very fast response. So you can detect it on the go, whether detection is happening at the patient level or at the cloud level, and you try to have some response to help the patient and save their life. So mobile and wireless services allow you to have different technologies on the go, and allows you to have the best type of technology that fits in a specific location. So for example, our mobile phone knows exactly that, well, once you have a headset, it knows to connect using Bluetooth. But when you get close to the university, it hooks up to the university wireless LAN. When you get out of the university, it hooks up to 4G. So when you move around, it knows exactly what is the best technology to use at this location. It knows automatically which type of technology I should be using in different locations. This allows you to be, on one hand, always connected. On the other hand, not only connected, but you are connected using the best connection. In one location, you may have different Wi-Fis. So it tries to do some measurement to find the best Wi-Fi at this point based on signal strength, and then it connects to that particular Wi-Fi. Okay? So within the same technology, you try to find the best, and actually from different technologies, it knows that you can move from one location to the other, and based on that, it finds the best connection for your location. Okay? So we'll just trying to discuss some possible aspects why wireless communication is actually important, why it makes that impact in our lives. And this talks about ubiquity, the fact that you are connected and you have access to any application services from anywhere at any point in time. And you have small devices like this, which has all the different wireless technologies built in, which allows you to to use the best type of connection at any point in time. Okay? So feel free to interrupt me if you have any question. Until now, we did not talk about specific techniques or issues or something like that. We're just talking high level, why mobile communication is important. Another thing which really affects our life, يعني, is the concept of smart techniques. Well, wireless has made it more smart, which means that you can have smart campus, you can have smart home, you can have smart hospital. Okay, and why is it smart? Because of the fact that you move around a lot, and with this mobility, you can be a source of information, or you can consume the information in a very intelligent way. So when you move around, your location changes. When your location changes, you can have access to different services. You can, we can push information to you based on your location. So location-based services have become really a reality, or they have emerged because of the fact that we are mobile. So location-based services is actually one of the big issues that many people working on for research. So you have smart school, where students, they have some wearable devices. When they get into the class, their attendance gets captured automatically. When they move around between rooms, their location is being monitored. Based on that, they get pushed some specific information based on the location they are in, and so on and so forth. So this is the location dependent services. So you have the ability to push information to the users based on their location, or pull information from specific servers based, again, on your location. So push or pull. Also, the fact that you have people moving around with some computational capability and some memory or storage capability, this actually triggered the use of collaborative caching or collaborative computing, or what we call fog computing. Okay? So all these devices, you can think of them as a repository for storing information and some processing unit. The fact that you have thousands of these allows you to have now new services that kind of leverage the storage and the computational capability of these devices in a huge scale. Okay? So you have collaborative caching and you have collaborative computing. So you can have a very sophisticated computation. If you distribute it among thousands of users, then it becomes easy, if you know how to do that. In fact, at some point, I had my laptop being abused or used as part of mining for Bitcoin, and I didn't know about that. There was like some Trojan on my laptop that works, throughout the night. It kind of dedicates all the computational power of my laptop for mining Bitcoin. I didn't know about that. Of course, mining Bitcoin requires sophisticated computation, but if you're using thousands of these laptops, you don't have to buy this humongous GPUs and stuff to use it for computation, right? It will be equivalent, if not more than, big GPU, which is worth thousands and thousands of dollars, right? So you can leverage thousands of devices to work for you. It's dangerous, but you can do the same thing. You can use it legitimately, of course. So you can use the computational capability of thousands of devices, which are mobile, and they can move around, or they can use different level of computation towards a big mission. So
how did you figure out that it is being
Yeah, good point. What happened is that in the morning, I usually find the fan of the laptop is like working very furiously. Like I hear the voice, which does not make any sense. It's like it's just weird. The fan is working too hard, and it's, well, I didn't do anything. I'm just leaving the laptop, and of course it sleeps automatically. Supposed to, but because of this process that is running on the laptop, it doesn't sleep. So when I heard the fan several days, I kind of suspected that. So I tried to download some software that detects Trojans and stuff, and it found the Trojan. So I looked up on the internet what this Trojan does exactly, and this is what I found. As we said, with all these fancy services and opportunities, there are always a disadvantage. So, of course, one of the things that that it's being addressed a lot these days is security and privacy. So with all these services, there is always some possibility to breach on privacy of people or on communication, which is supposed to be private communication. So privacy here talks about revealing the identity of people, which is not supposed to happen. And security talks about confidentiality, or talks about hiding the communication. And of course, in wireless in particular, it's a little bit tricky. We'll talk about why. So this shows the different types of wireless devices and how they evolve in terms of performance. So in terms of performance, you have like sensors or embedded controllers which have very, very, very low capability of computation and very low memory, very low storage computation. To mobile phones, the old mobile phones, of course, we don't have these anymore. To some tablets, and of course, we have now smartphones and we have laptops. So each of these types of devices, they have more storage and more computational capability. And nowadays, we're talking about the concept of convergence, that you have different capabilities using the same device. And we'll talk about the same concept for wireless communication. So, so using, for example, iPhone or Samsung phone, you can have significant storage. You can have, in fact, some of these devices are like octa-core, so they have 8 processors built in, like integrated somehow. In laptops, we also talk about 2-in-1 laptops, that it's like touch screen, and so you can use it as a tablet as well as a laptop. So there is the concept of convergence. So one device can be used for multiple purposes. And this is nowadays possible because of the nanotechnology and all the sophisticated hardware, which makes it possible to have one device with reasonable size, and it has multiple functionality in it. So in the past, this was not possible because the hardware designed for such devices does not allow multiple usages of that device. So we used to have laptops bigger in size, and they don't have any touch screen in them, right? Or phones or mobile phones, which are maybe bigger in size, and they cannot be used for sophisticated processing. So nowadays we can use phones as big processors, and we can use notebooks or laptops for touch devices and similar to tablets and so on. Type. What is the effect of portability? So starting from here, we'll talk about some issues related to wireless. So the effect of portability Portability always causes the fact that your device has to be small enough to be able to carry it around. And this creates some limitation on the computation. So, of course, we have laptops that have a significant amount of computational capability, but they are nowhere close to big workstations that have very sophisticated CPUs and GPUs and so on, right? So there's no comparison. We cannot have GPUs that are portable, at least until now, and laptops that are portable, they have reasonable computational capability. The fact that the device is also portable, like these phones, it makes the quality of the displays less, although of course there are very sophisticated technologies like OLED and stuff. The screen itself is good, but at least it's small in size. It's still small in size to be able to carry it around. And this affects the design of the applications. So you cannot have huge amount of information on this small screen, or the person or the user cannot actually see this huge amount of information on one screen. The storage capability is limited due to limited battery capacity. In fact, one of the limiting technologies, in my opinion, until nowadays, is battery technology. So this is one of the biggest limitations that we have nowadays, which does not progress and evolve with the same pace like any other technology. And that's in a way limits some design of devices, and it really affects many standards and technologies. The fact that the capacity of certain batteries is still limited. So this also affects the loss of data. The fact that you can have something portable makes it easy to steal, or makes it easy to lose, which means you lose in the entire data on this device. So nowadays, of course, we put everything on the cloud, and we can access the data from anywhere and stuff like that. So limited user interfaces, we talked about that. So there is also some usability issues, like compromise between how to use the phone and the size of the display and stuff like that. There is some limitation with regards to integration of voice recognition and things. Although nowadays it's this text is rather old, so nowadays we have overcome some of these limitations. Actually, even on the phones now we have Sys3, and we have this and that for voice recognition, and we can give some voice commands to the phone to get to Google Maps and stuff like that. So some of these services have been overcome. So limited memory, at least in relation to big computers, it limits the usage of massive memories with moving parts. And we have now flash memories which are in the size of like 1 terabyte. So, but the problem is that every time we have new technologies, the applications themselves, they evolve in the fact that these technologies become limiting. So, so nowadays we have a flash memory in the size of 1 terabyte, right? But applications evolve, and we have big data, and maybe 1 terabyte can be collected in one day from certain applications, like big social networks and stuff. So, so this 1 terabyte becomes really very small compared to how much data can be generated from certain types of applications. So in other words, portability puts some limitations on the size, on the usability, on the memory, on the computation, on the power in our wireless devices. And these limitations affect the type of applications that we can run on these wireless devices. So this is with regards to mobility. With regards to wireless networks, with regards to the wireless signal itself, we have higher loss rates due to interference. So when we talk about the wireless signal itself, so now we are communicating through these devices, okay? And there is wireless signal in the air. So now we talk about some of the characteristics of the wireless signal. Well, wireless signal, unlike wired signals, they have higher possibility of loss due to interference. Because the wireless signal is just like electromagnetic wave in the air. So it gets affected by everything in the environment. It gets affected by all the obstacles. So there are many, many sources of external interference that affect the wireless signal. Some of them are obstacles, and other sources of interference is another wireless communication which is happening concurrently, okay? And it happens to use the same wireless channel or the same wireless frequency. So two wireless communications, they interfere with each other. So there is cross interference between two wireless signals, and there are some external interference which happens from obstacles. Even your microwave and appliances at home, they somehow form some type of external interference to your wireless communication. And I'm not sure if you have noticed that, but sometimes it happens if you have some wireless communication and someone opens like a microwave or opens like a vacuum even or something like that, it affects the wireless signal. So we'll talk about really the characteristics of the wireless signals in details, and then we'll talk about the characteristics of this wireless signal in different frequency ranges. Because when we talk about the characteristics of the wireless signal in low frequency, it's different from high frequency, it's different from very, very high frequency, it's different from ultra high frequency. Okay? So these types of wireless signals in different frequency, they have different characteristics altogether. So we also touch a little bit on regulations of frequency. Well, because of the fact that these frequencies are commodity, so we need to have certain regulations to access certain range of frequency. So in fact, when you as a manufacturer design or when you manufacture a certain wireless device, you need to pay a lot of money to the regulator, in which case it's like a regulation body. You need to pay the government certain amount of money to be able to use certain range of frequency. Okay? Of course, there are some frequency bands that are exempted from this, and we'll talk about that. But by default, in order to access certain frequency ranges, you need to pay some money. You need to have some license fees. And that's why when Ooredoo releases, like for example, a new network, or any, like Vodafone, when they came in, when they released their network and stuff, they have to pay lots of money to the government to be able to access certain frequency range. And they pay millions of dollars. So, so the frequency regulation is a big, big issue. We'll talk about how we do frequency planning. It's a huge issue, actually, to be able to control the different frequency ranges and what service providers and how service provider access different frequency ranges. We talk about transmission rates and how they get affected by frequency ranges and how they get affected by some other factors like power, transmission power, and so on. And it's very important to understand how the power and the frequency range and all of this affect the transmission rate. What is the relationship between them? Because then we can say that because this type of standards uses this frequency range and uses this amount of transmission power, then the maximum transmission rate is this. There are some equations that sort of govern or control this relationship somehow. Okay, so we'll talk about this. So, for example, GSM. GSM was not designed for data transmission, was mainly designed for phone calls. There is a big difference between the two. So in the past, we didn't have any data plans or data services on the broadband networks. Broadband networks were originally designed for voice calls. That's it. We didn't have any data. GSM introduced GPRS, which provided some very low data rates, like 150 kilobytes or something, or kilobits per second, which is very low transmission rate. Okay? So we'll talk about how GPRS has been integrated with GSM. But then later on, we had other like extensions of GSM towards 3G and 4G, and now 4G can support hundreds of megabits per second. So how did this happen? How did this happen in terms of cellular architecture? How did the architecture of the cellular standards change to provide these high transmission rates? What has changed in the standards? Well, technically, we have to change the transmission power levels. We have to change certain frequency. We have to change bandwidth. We have to change lots of things to make this happen. And this does not happen easily. This requires significant changes on the hardware, which requires replacement of the entire infrastructure in the country. It's not easy. Okay? Higher delays depending on what technology you are using. Whether this technology requires connection establishment or not, we'll talk about circuit switched versus packet switching, and how the circuit switching requires the establishment of a virtual circuit, and what time does it take, and so on. Of course, with wireless, as we said before, comes the threats, and because wireless supports the broadcast of a wireless signal in the environment. Okay? So when we talk about wired, we talk about specific signal going into wire. So unless you cut the wire and get into the middle, you cannot get access to the signal inside the wire. With wireless, we don't have that. It's just a signal which is broadcast in the environment. So anyone can detect this signal and can read something from it, right? So this fundamentally changes the concept of security. So wireless security is always very challenging. So we even nowadays, I don't know if you've watched this video of a replay attack when a guy like walks closer to a person with this car keys, and he reads the signal from these car keys, and he replays this because the technology is based on very, very short range. Okay? So if you read it from a very short range and then replay the signal, you can increase the power of this signal to allow it to transfer very far. Okay? So when you read this signal and replay it with higher transmission power, then you can transfer this signal over long range to another person who is close to the car, and he can open the car and get in very easily. So this is based on wireless. So wireless makes it more attractive and easier for people to attack, to have like active attacks. Okay? So with all these fancy things we're talking about, there are some threats, and that's why with the proliferation of wireless technologies and services, nowadays they started to realize the effect of this on security and privacy. So that's why nowadays they started to appreciate this kind of threats, and that's why wireless now is one of the hottest topics in this country and in every country because of wireless. Okay? So wireless provides always shared medium. You can never have, well, you can almost never have point-to-point communication. Like in wire, you can have point-to-point. You can have one wire between two devices to communicate, right? So there is no sharing in that case. But with wireless, you cannot have this luxury. It's always shared, whether you accept it or not, which makes your communication prone to attacks. Okay? احنا خلاص we'll stop here.